Dear students, let's start lecture number 16 on the topic data encryption standard algorithm. Normally it is called DES algorithm, and this is part number one. We will be having four parts. This is a very big topic of network security. So we will be discussing data encryption standards in four parts. So this is part number one. So let's get started with with the outline. So first we will revise lecture number 15. As you know, the lecture number 15 was on the topic need of fiscal block structure, and then we will be discussing fiscal block structure processes like encryption process, decryption process, and number of rounds it takes. As you know that this is today our topic is data encryption standard, and this standard is based on fiscal block structure. So this is the you may call it that this is the continuation of fiscal block structure. But fiscal block structure, this was a generic model, and DES is a specific model. So in the DES today we will be discussing important information of DES, general structure of data encryption standard, initial permutation. This is the first step of DES. So today we will be discussing the first step of DES, and this is called initial permutation IP. And then we will be discussing round number one. As you know that data encryption standard, this consists of 16 steps, so 16 rounds, but we will be discussing only one round in detail. So if you know that how it performs in round number one, you can easily understand the rest of the rounds, because all the rounds they perform the process in the same sequence. So that's why we will be discussing round number one in detail. So if you know the working of round number one, so then you can easily understand the next rounds up to 16. Then I'll give you assignment, and then you have question answer session, and then references, sources which we have cited. I'll discuss that. So so let's start with a revision of lecture number 15, which was on the topic fiscal block cipher structure. So now fiscal block cipher structure, as it is mentioned, that not a specific scheme of block cipher. This is not a specific scheme. This is generic model. Anyone can use this model to make its own block structure or block cipher structure. So as you know that normally there are two type of conversions, like you have you have a stream cipher and a block cipher. In a stream cipher, you will take one character and convert it, whereas in block cipher we will take more than one character and convert it into ciphertext. So this is block cipher. And design model of fiscal block structure, many different block ciphers are derived from it. DS is an example of this, as today's our topic is on DES, so we will be discussing this in detail. Fiscal cipher structure uses same algorithm both for encryption and decryption, because this is symmetric encryption model. So as you know that in symmetric model, both uses the same mechanism, same key for encryption and decryption process. And then we will discussing different processes which are involved in fiscal block structure, like encryption, decryption, and number of round it takes. Now, encryption process. In encryption process, input blocks divided into two halves. Like you can see here that you have a plain text box divided into two halves, left and right, and you can see that we have a left and we have a right half. So they will be divided, like you can see that two divided, each round the right half of the block set for R goes through unchanged. You can see here that R is passed, and this is goes to left side, left without making any change in that. So this remained unchanged. The left half L goes through an operation that depends on R. So you can see here that here the operation is performed that you have a key and you have a key involved in it, and then you will XOR, we will perform the process of XOR on left side and pass to the right side. So the left half goes through an operation that depends on R and the encryption key. So encryption key, you have encryption key and you have an XOR process. Apply encryption function. If you have a F function here, takes two input, like you have a key and a R. The function produces the output FRK. So this is the result of this will be XORed with the left and passes to the right side. The function produces the output this and XOR the output of the mathematical function with left. So you can see here that R goes to left side without making any change, whereas left side, on the left side you perform the process like KR, and then this will be XORed with left side and passes to the right side. Now, in encryption process, in the real implementation of cipher, fiscal cipher such as DS, instead of using the whole encryption key during each round, a round dependent key or a sub key is generated, derived from the encryption key. Each round uses different key, so each round will be using different key. And why this is going to perform, why we take different kind of keys, because we want to make our data more secure. So sub keys are related to the original key, so there will be a sub key generator. So you have a key, and for each round a key generated key there will be operation that will be generating a sub key from the original key. Permutation step at the end of each round is performed, and then it is swapped. The left the modified L and unmodified R. The left for the next round would be R. The current round R for the next round be the output L, the current round. You can see here, I will explain, I have already explained this in my previous slide, that you divide the plain text into two halves, and right half passes to the left side without making any change, whereas on the left side we perform this function, and then this will be XORed with the left side and passes to the right side, and at the end the process of permutation is performed, and you will get the cipher block. Now you can see here that this is these are the two formulas for the left side, like you can see here, that for the next left level you are getting previous R. So without making any change, right will be assigned to the next layer of left side, whereas the right side, you can see here the function will be performed XORed with the left side, and then this will pass to the next round right side. So this is how the process will perform on encryption. So this each round will be using this formula, as there is no restriction in fiscal blocks cipher. As many rounds you want to take, you can perform this operation. Now, process of decryption. Process of decryption, this is performed in the reverse order. You can see here when the cipher block is received. So you can see here that the right will be going here. Right will be going unchanged to the right, to the left, whereas here left side is going to the right side without making any change, and the function and XOR will be performed on the right side, and then will then it will be assigned to the next layer. So you can see here, this is right. So the next of L will be the right side. And for the left side, you have a next right side, right side around, and you can perform the function on K and L, and this will be assigned to the previous left side. Yes. So this process will be performed in reverse order to take your plain text back. So this process is performed by the receiver, and the process which I have shown in my last slide is performed by the sender. Now, number of rounds. So as I mentioned, that there is no restriction in crystal blocks cipher, because this is not a specific model. As DES, data encryption standard, this is a specific model, but crystal block cipher, this is generic model. So you can use as many rounds as you want, but you must know this thing, that on what would be the pros and cons, or a trade-off. Like you can see, the number of rounds used depends on the desired security from the system. For example, if you want more security, you will be adding more rounds. Advantages of the more rounds, more number of rounds provided, more secure system. But the cost of the more rounds would be that more round means inefficient, because as you know that you are increasing rounds, and in each rounds there is a number of mechanism and some calculation and mathematical operations, they are being done. So you know that you will have to pay the cost in a you can pay costs in a shape of inefficiency. So the number of rounds in the system depends upon efficiency, security trade-off. So this is you can add as many rounds as you want, but more round will be giving more security to you, but you will have to pay the cost in the shape of inefficiency. Now, let's start today lecture on the topic data encryption standard algorithm, which is normally called DES, and this is part number 1. Data encryption standard, this is developed by the National Bureau of Standards, NBS, in 1970, and with the help of National Security Agency, and this is approved in 1979. And this is a block cipher, as I mentioned, that this is based on crystal block cipher. So this is, as crystal block cipher is based on block cipher, so this data encryption standard is also based on block cipher. Encrypts data in block size of 64-bit each, produces 64-bit cipher text. Key length is 64-bit. Originally consists of 64 bits, 54 bits are used by the algorithm. As you know that each bit of the each 8 bit of a byte will be used for the parity checking. So the 8 bits will be discarded, so you will be left with 54 bits. 8 bits are used solely for the checking of parity. So as I mentioned that each 8 bit of a byte will be used for the parity checking, and they will be discarded thereafter. Consists of 16 steps. So as I mentioned that in crystal block cipher, that was a generic model. You can use as many rounds as you want, but DES is based on 16 steps. So 16 rounds will be involved in data encryption standard. Each one is called as a round. So each step performs the step of substitution and transposition. What is substitution? Substitution is called as confusion, and substitution is called as diffusion. Now, some more details about data encryption standard. So this is based on symmetric key block key, As you know that fiscal block structure that was also based on symmetric key. So as DES is based on a fiscal block structure, so this will be uh, this will be the same. Like this will also be using the same symmetric key block structure, means for the encryption and decryption, same key will be used. Published by the NIST, National Institute of Standard and Technologies. DES is a block cipher. This is mentioned previously. General structure of DES you can see here. Like you will pass plain text 64-bit. So this will be passed through the data encryption standard, and you will get the 64-bit. As you pass 64-bit plain text, so definitely you will be getting 64-bit cipher text. And here you have a key through which you are making your data secure. But as I mentioned in the fiscal block structure, that we will be having a one key, and using that key, sub keys will be generated. And who will generate that keys? There will be a key generator. That would be generating sub keys for each round. So as in DES we have 16 rounds, so 16 sub keys will be generated. Similarly, when when the receiver receives the 64-bit cipher text, so DES structure will be cipher will be applied again, and you will get back with the 64-bit plain text by applying the sub keys, 16 sub keys, which is generated by the key generator. So you will convert that and get that plain text back at the receiver side. So this is general structure of DES. You can see here, like you have 64-bit plain structure. In the previous slide, if you see, this is, you may call it, this is very abstract kind of a model. But here I have shown this in detail, that what are the steps that are involved in data encryption standard. Like in the 64-bit text, you can see here the first we have an initial permutation. As this is our topic of today, so I'll be explaining what initial permutation is. So then after receiving this will pass to the round number 1. And then we have 15 rounds here, and then we have 16th round, and then finally it is passed to the final permutation, and finally it reaches, finally it produces 64-bit cipher text. And here you can see that this is a round key generator. Here you can see that you have 48-bit sub keys are generated from this, and 56 bits cipher block key is passed to the generator, and generator will be generating 48-bit sub key for each round. So there would be 16 sub keys that would be generated from this 56-bit cipher key. So 16 keys, you will be having 16 keys. So this is how you make your data more secure. Now, initial permutation. This is the first process of DES. As you know here, that once you pass 64-bit plain text, it reaches to initial permutation. So this is the initial permutation. That what happens in initial permutation, that happens only once. So this is performed only one time. As you know that in a DES, we have 16 rounds, but this is on the top of all those. So this will be performed once. So what the permutation is, this is nothing but jugglery bit position of the original plain text. Suggests how the transposition in initial permutation proceed. For example, the initial permutation replaces the first bit of the original plain text block with the 58-bit. This is general example that, for example, you can see here that first is replaced with the 6th one, and 4th is replaced with the 2nd one. So this process will be going on, and all the bit position will be changed. So with the 58 bit of the original plain text, the second with the 58 bit of the original plain text block, and so on. So in the permutation, you may call it that just just the position of the bits will be changed. So you may call it a jugglery of bit position. After initial permutation is done, the resulting 64-bit permuted block divided into two 32-bit blocks, and you may call it RPT and left, and you may call it right plain text and left plain text. So you can see here that here we have passed 64-bit plain text, and it reaches to initial permutation, and in initial permutation does that, first it performs the jugglery of bit positions of the original plain text, and then it divides into left plain text and right plain text of 32-bit each. So 16 rounds are performed on these block structures. Now, after initial permutation, it reaches to round number 1. So round number 1 is consist of all these steps, like you will be performing key transposition, expansion permutation, S box substitution, P box permutation, and XOR and swap. So today we will be discussing key transformation. So key transformation, for each round a 56 bit available from this 56 bit key are different 48 bit sub keys generated, as I shown in my previous diagram. During each round, using a process called transformation. So that's why this is called key transformation. The 56-bit key is divided into two halves, each of 28 bits. These halves are circularly shifted left by 1 or 2 position depending on the round. So there are some round, like I'll give this explanation in my next lecture, that what are the rounds. I forget to mention that this depend on the fixed number of round, like you have 1, 2, 14 and 15. So on that you will be performing 1 bit shift, and on the remaining you will be performing 2 bit shift on left side. After an appropriate shift, 48 of the 56 bits selected, the key transformation process involves permutation as well as a selection of a 48-bit subset of the original 56-bit key. It is called compression permutation. So you may call it, this is compression permutation. So this lecture will be continue in part number 2. As I mentioned, that this is a very big topic. So today we have only discussed initial permutation and key transformation of the round 1. So this lecture will be continued. So these are the sources which I have cited. You can check these sources and find more details about this topic if you are interested, or if you have any kind of problem in that. So if you have any question, you can ask me through WhatsApp or a KCMS, or you can call me. You have my numbers. You can call me, and I'll be more than happy to answer your questions. So with that, I would like to thank and see you in next lecture. Allah Hafiz.